Myself, Dr.S.Kanchana, Assistant Professor, Department of Physics, Seethalakshmi Ramaswamy College, Trichy. I am going to explain BCS theory under superconductivity. Before going to BCS theory, a small introduction about superconductors. What is meant by superconductors? A material having a zero resistivity is called superconductors. It was first discovered by Dutch physicist Kamerlingh once in 1911. Depends upon the resistance, the material can be classified as conductors, semiconductors, insulators, and superconductors. What is the cause of a resistance in normal conductor? A solid material consists of a positive lattice ions and more number of free electrons or valence electrons having a negatively charged. These lattice ions are always in a vibrating state due to its thermal energy and room temperature. The free electrons are flowing through the vibrating lattice ions. As a result, these free electrons and the vibrating lattice ions get collide with each other and loses its kinetic energy in the form of a heat. This is the reason for the resistance in normal material. Why the resistance does not happen in a superconductor? As we discussed earlier, that the lattice ions are always in a vibrating state due to its thermal energy at room temperature. So, when the temperature decreases, the thermal energies also decreases and the vibration of the lattice ions get reduced and finally it stops. So, when the temperature reduced, the resistance also reduces and the conductivity increases. It was experimentally observed with the help of a mercury as a sample. It is shown in this graph that when the temperature decreases, the resistivity is also decreases. Suddenly, at a particular temperature, that is, at a 4.2 Kelvin, the resistance becomes zero. This temperature is called a critical temperature Tc or a superconducting transition temperature. This critical temperature varies for each and every material. Below this transition temperature or a superconducting state and above this critical temperature, the material is said to be a normal state. Pure material or a type 1 is better and easy to lower the temperature than that of a material consists of impurities or a type 2. Type 2 have a very high critical temperature, so it required more amount of energy to lower the temperature. Now, let us see BCS theory. Type 1 superconductivity was well explained by John Bardeen, Leon Cooper and Robert Scheriffer in 1957. This is also known as Bardeen-Cooper Scheriffer theory or BCS theory. They received their Nobel Prize in 1972 for the development of this theory. As the temperature decreases, the thermal energy decreases and the vibration of the lattice ions get reduced and finally it stops. It is shown in this figure that the larger circle is a lattice ions and the smaller one is an electron. So there is no collision between the positive lattice ions and the free electrons. But instead of a collision, there exists a Coulomb force of attraction between the positively charged lattice ions and negatively charged electron. As a result, some distortions may be created in the lattice. These distortions are mentioned in this figure. The extent of the distortion or displacement of lattice ions depends on the cohesive energy between the lattice ions. If a cohesive energy of the lattice ions is less, the displacement will be more. Consider this electron as a E1 and this electron as a E2. The electron E1 will be shielded from electron E2 by the cloud formation of the positive lattice ions around it. When electron E2 move closer to electron E1, there exists more attraction than that of a repulsion between the two electrons. Actually, it is not the attraction between the two electrons, it is the attraction between the electron and the lattice ions. So, the second electron E2 enter the cloud of E1 and bonded as a single particle called a Cooper pair. How it is bonded? The electron E1 get bonded to electron E2 by the exchange of a packet of lattice vibrational energy called a phonon. The electron E1 with a wave vector K1 distorts the lattice and emitting a phonon of wave vector Q. So after collision, its wave vector changes into K1 minus Q. This K1 minus Q represents the electron loses its energy. The another electron E2 with a wave vector K2 takes up the energy of a phonon down the lattice. So after collision, its wave vector changes into K2 plus Q. So what is called a Cooper pair? A pair of free electrons coupled through the exchange of a phonon, quantum of lattice vibrational energy is called a Cooper pair. This pairing can be broken only if any energy equal to that of the binding energy is applied, so that superconductivity does not occur at a high temperature. Cooper pair can maintain this coupled motion only up to a certain distance called a coherent length. These are the reasons for superconductivity. In normal conductor, single electrons are scattered by vibrating ions and experiences opposition to the flow. So, the resistivity rho does not equal to 0. But in a superconductor, Cooper pairs are formed at a very low temperature and are not scattered by lattice ions. So the resistivity rho equal to 0. Also, Cooper pairs do not transfer their energy to the surroundings in the form of a heat. These two properties, that is, no scattering and no energy transfer, explains the zero resistivity of a superconductors. These are the characteristics of a Cooper pairs. Electron have opposite spin and opposite momentum. Single electron fermion which obey Pauli's principle. Cooper pairs boson which does not obey Pauli's exclusion principle. Mass and charge of a Cooper pair is twice that of a single electron. Volume occupied by a Cooper pair is twice that of a free electron. Binding energy is very low, that is approximately equal to 10 to the power minus 3 to 10 to the power minus 4 electron volt. That's why superconductivity happens at a very low temperature. I conclude the lecture. Thank you.